welcome everybody.
We're on. All right.
We are on, man. It's welcome back to What's the Hazard, as we say. It is Friday, I believe it's April 11th, maybe, if I'm not mistaken.
Yes, sir.
It's supposed to be a beautiful day in Omaha, Nebraska. I envision sitting on a patio somewhere this afternoon at happy hour, perhaps.
Yeah, that'd be great.
See how that goes.
Yeah.
My guest, if you've been doing safety EHS stuff in the Midwest over the last 20, 25 years, you have definitely run into Jason McMeen. You have been a big part of this safety world, our safety community, for quite a long time.
I suppose so.
You travel quite a bit. You hit a lot of places.
Quite a bit.
You do a lot of conferencing. You do a lot of those things. So you're probably a familiar face to just about everybody that watches, other than my mother, maybe, or maybe not.
I saw her last week.
Did you? Okay, right. She had some challenges. You were exactly, but I think everybody probably knows you. They recognize you, and you've got some exciting news, man. You've had a little change in your life, which
a little bit.
Yeah, let's talk about that.
A little bit of full circle change.
Yeah, interesting. You say that. Tell us what's going on.
So, in my past, well, do we want to go through all the past or just cut to the chase?
Well, you can go through the interesting.
Basically, my start in the safety industry, I started in EH&S and then went into the private sector and started a safety division for a distributor.
Okay.
That did machine tool work. And so that led into looking at a part of doing machine safety. And that was then hooking up at that time with Rockford Systems and working for that distributor.
Okay.
Well, then 2008, 2009 hit, and the industrial world imploded. Yeah. And I kind of thought to myself, well, the distributor decided they weren't going to really chase that side of the more interesting safety products, the more consultative safety products. So I'm like, well, I can do this myself.
Yeah.
And so I partnered up and started my own business with Rockford Systems and did that for a long time. More consulting and also machine guarding and things like that. And then got into some people asked me to go do some other things for a while, and I just got done working for Impacto Protective Products doing more ergonomics. And then Rockford Systems came to me and said, we'd really need you to come lead our approach and our sales to go out and proactively talk about what we do.
Right. Well, you were just describing that to me. Traditionally, the model had been somewhat reactive. People would have an immediate need based on an incident or fatality or something horrible, and that they would drive them to Rockford.
Blood marketing is what I call it. Yeah.
Oh, my God.
Basically.
Somebody
gets hurt, and they call them and say, we need you.
I get that a lot, too, frankly, unfortunately.
Yeah.
But I love the proactive concept. They want you out there introducing people to these concepts, these solutions,
and letting people know what we do and that we're out there doing it. It's.
I mean, if I may say, Rockford is the preeminent guarding organization in the United States, if not the world. I don't know much about the world, but
the United States for sure, and then reaching out now with U.S. companies into Canada and Mexico too. So the North American space is what we're doing, and yes, like if I look at the customer base, it is the top companies in safety in the world that partner up with Rockford.
Very cool.
Yeah,
that's very cool.
So I probably can't talk about companies, but if you think of the top companies that you think of in the world of safety, they use Rockford as their person to come in and do the work. So, and how Rockford works is you'd have them come in and assess all your equipment. They'll give you a proposal on how to fix it, and then if you want, they'll come in and actually do the whole turnkey process. So, and then we also have training and things like that. So, but yeah, the whole full circle thing is now I'm back to doing machine guarding, which I did for my own business.
Right. And so when we met, you and I met, it was at I think it was the Nebraska Safety Council. It may have been James Clark was kind of their OHS guy back then. There was a conference down in Lincoln.
Yep.
You had a booth down there. If I'm not mistaken, Springer was there too.
Oh, Springer's probably everywhere I go, and likewise.
Back in those days.
Yeah.
So this had to be the mid-'90s, I'm guessing, late 90s possibly.
Yeah.
Does that sound about right?
90s, yeah.
And you were doing the machine guarding then.
Mm-hmm. That was for a distributor at that time. Yeah.
Fantastic.
Yeah.
And I think that was probably when we initially met, and now we've been just like running this, following the same tracks for a long, long time.
It would have been me, and then Jeff, and then Dale Kugler was around.
That's right.
Too.
Yeah, Kugler, absolutely.
So
the usual suspects.
Yeah,
But this is really exciting, man.
Yep.
I mean, the machine guarding is something that everybody is responsible for. We talk about, you were mentioning ergonomics earlier. You'll see a few companies show some interest in ergonomics occasionally, but everybody has machine guarding needs. I mean, construction, industry, healthcare, everybody. It's just a huge. And then the options, I know you brought some stuff to share with us, but the types, the devices versus the guards versus all these different things, which makes it somewhat complicated, which leads to having someone who knows what they're talking about help with that assessment, make that evaluation. It's not easy.
No, so there's the easy stuff, and we'll talk about some of the guarding and the easy stuff. But even beyond that, once we get beyond that, it's get a little difficult, which is why Rockford Systems and its engineering department is critical.
Right.
To make sure that the machine works how it's supposed to work.
Right.
And that's part of the machine guarding whole concept is you don't want to show up and you want to know every day that it's going to be the same and that it's going to be safe. And that's the whole backbone of it. That's the complicated part.
Yeah, most definitely.
But no, I mean, we want to jump into like the groundwork.
You stop in anywhere you want, man.
I mean, I guess we talk about why.
Well,
why even do we want to care about this?
You've seen this for a long time.
Yeah.
Why is it important?
Well, I think about it as machine guarding. I have, of course, stories when we talked about how Rockford gets their business because something happens, and but you can think about it in this way that when you put your workers and they're working on a piece of equipment, it doesn't matter what piece of equipment. I think of it like, if you're walking across the street and you're in traffic, you want that light to be red. Well, what if one time it's green and somebody just plows through you, right? And out of the 100 times, that maybe happens once. Well, you don't want that to happen once because when it happens, the consequences are drastic.
Yeah.
You can go run your hand across a sharp piece of metal and get cut. You're back to work. It's fine. The machine guarding stuff, if something happens, life-altering, company-altering, as a safety director or as an owner of a business, that can be life-altering for you also.
Absolutely.
So it's a little bit different consequences, and that's why it matters for us to look at this, just because if something goes wrong, it's disaster.
It usually is. It's usually catastrophic.
Yeah.
No doubt.
Yeah, and catastrophic can even be, missing or losing use of your hands or digits. I mean, that's life altering. So it doesn't have to be fatality.
Right.
Sometimes it is. But I mean, even just some of the other injuries, you don't have a minor injury with a machine accident.
Typically. Yeah, and I know you've seen many instances of that. I did when I was with OSHA.
Yeah.
Unfortunately, lots of those. Oftentimes, just horrific. Young people that are having these issues. Run into these machine issues and stuff. It's just
old. It doesn't.
It's horrible, man.
It doesn't pick.
No, it doesn't. And the equipment doesn't care.
No,
I mean, the equipment doesn't distinguish. No. It doesn't matter what it's cutting off or punching holes through or whatever.
Yeah.
So what drives this? I mean, there are ANSI, the OSHA. You want to talk a little bit about?
Yeah,
what
it all began with OSHA's regs way back in the 1970s, and the one to really look at is OSHA 1910-212, which is just general machine guarding standard. And then if you have specific machines like a mechanical power press and forging presses and things like that, they have specific regulations also. But if you just look at it as a umbrella, 1910-212 just says, hey, if you got a piece of equipment and there's a hazard on it, you got to guard it.
Yeah, exactly.
And guard it just means keep people out of it. So guarding is a way of, like, this is guarding when you talk about the industry, and then these are like devices. But when we talk about guarding, then OSHA reg also in that same regulation actually comes out of 217 though is there's a guarding standard, table O-10, and that's what we look at when we're guarding.
Right.
And we got the little stick here that is the guarding stick per se.
Yeah, the
So if you
gotcha
have
stick as we
I
call
didn't
them.
want to say that.
Is that a trade name?
I don't know. Sounds
what I
vicious,
call
right?
it. The gotcha stick.
Because you always think like an ocean inspector is out there going, gotcha, but that's not.
That's not quite what it meant.
That's not what it's for.
Exactly.
We're going to be kinder.
But can you show how that actually works for people that have never seen a gotcha stick?
So, first of all, this is a physical way to show the standard. It's a distance and a measurement like how small of an opening can be as close to the point of operation hazard. So, so when you have a piece of equipment, you have a point of operation hazard where the work is being done or where there is a crush or pinch point, or we can talk about different things. But, I mean, wherever you're going to get hurt, then the guarding has to meet this criteria. And so if you had a piece of guarding, it's kind of hard to see. But we can come all the way through. Well, we got to put it out here. Look at that.
There you go. There you go.
Whereas, and this is an inch, I believe, and then that would be dramatically different.
So the depth of penetration there that it's going through the guard shows you how far, like
you can go.
The size of that guarding space based on how close you're going to come to that action, that hazardous action.
So there's the point of operation out here.
Yeah, that's really cool, man.
And this style right here is usually used for more perimeter guarding. So keeping people out of an area, whereas this style is used for if the action is being done right here.
Okay.
So when you think about like perimeter guarding, you think like robots or automated centers.
Yeah.
And this is more like the machine that's right there, the punch press, the whatever.
Okay.
That type of guarding.
And you might be sitting right in front of that.
Correct.
Something like that. Okay.
Yep. And it might be your primary way of getting you out, or it might be secondary where you have palm buttons that keep you there, or a device.
Okay.
So guarding, and then safeguarding devices.
And so what is that?
So this is a set of light curtains.
Light curtains, okay. Yeah.
So these would go across, and there'd be infrared beams coming across. And then basically they just are a field that when interrupted, the machine stops through the electrical controls.
So, but OSHA doesn't dictate, like you mentioned 212, 1910.212. It
Correct.
doesn't tell you specifically, if you have this application, you must use this.
Nope.
You have to figure that out, which is part of the challenge.
Correct.
And there might be multiple, you might have multiple of these different solutions on one piece of equipment.
Yeah.
Which is interesting.
And then actually you'll see both of the physical guarding and the light curtain in conjunction together sometimes.
Excellent.
So let's talk about that for a second. I've got a couple stories. Physical guarding. So I show up on site, and you're the safety guy, safety person, and you're like, hey, let's go look at these equipment. And I often will see all of a sudden when I walk up to a machine like a door close or a piece of someone scramble and throw up the guard, right? So safety guys around, let's put this on. It's like, okay. So this has to be fixed in place so that someone can't do that. A guard has to be fixed in place, meaning it has to have some attachment to the piece of equipment or to something solid.
Okay.
Could be a post, could be something, but it has to be attached with a device, or actually can be a fastener or something that needs a tool to be removed.
Okay, yeah,
so it can't be a wing nut or something like that. Can't be a zip tie that's easily defeated, although that's been used before.
Yeah.
But it has to be something that you need a device to take off.
Fixed guard,
or it can be interlocked. So you get a guard that's interlocked, and an interlock is a device that talks to the control, and basically if this thing closes and the interlock slides into itself and there's a key that goes in. So think of like a door lock where there's a key that goes in.
Right.
And then it signals to the machine, okay, you can operate.
Okay.
If that key comes out, it says, hey, machine, turn off.
Okay.
Or turn off production. It doesn't mean turn off completely. So interlocked or fixed, and use a type of securing device, whatever it is, that needs a tool to open it.
Okay.
So that's and that story is, the story is, you come out there and then somebody's taking it off, or you look at a guard and you're like, why isn't it on the piece of equipment? Oh, well, it gets in the way or something.
Right.
You're like, well, you shouldn't be able to just remove it.
Mm-hmm.
It should be on there all the time.
Interesting.
And so then,
this is kind of a rhetorical question to some degree, but just so people understand this, if I can easily remove that guard, could I be cited for that?
Oh, yeah.
I mean, that does not meet the requirement of the regulation.
No, exactly. If
I've seen guards hung on stuff. You just unhang it. And
then it's a shield, not a guard.
Right, exactly.
Right? I mean, if it's a...
Right.
So, one of the things about the other thing about looking at guards is they call it like outa, which is over, under, through, around. So that's the other thing you got to look at. If I have a guard in place, can I go over it, under it, through it somehow if there's an opening, or around? Mm-hmm. That's the other criteria. Mm-hmm. And when you get into some of there's some other standards out there, ANSI standards, that will describe further what that means.
Okay.
On some guarding scenarios. So,
okay. But that being said, if you put that fixed guard in place, but I can just reach over the top of it into the danger zone, it has not done what it's expected to do.
That's not a guard.
Yeah.
That's just an object kind of in the way.
right. That's just an annoyance, actually.
It's just an obstacle for them to figure a way to get
more creative. Yes, interesting.
Exactly. And through, because I've seen people just cut out the center of it.
Right.
You're like, oh, I'm just going to cut this out.
Because otherwise I can't reach in.
Yeah, I can't grab it in there, and I can't, or even if they use a tool or whatever, it's still like, guys, you can't do that. Like,
yes.
Like, let's not do that.
But what about the fixed guard in I can imagine it is, permanently in place, not easily removed. It prevents that over, around, under approach to the danger zone. But these devices, I mean, that's not quite as clear. I mean, they are, if you're interrupting that beam, they are sending a message to the control circuit, to the PLC or whatever, that shut down or stop at least production.
Right. It'll stop the run feature, whatever that is.
Okay.
It may not turn off the piece of equipment. Let's hope not, because there's a bunch of things that are going on there that still need to be powered.
Right.
Yeah.
Okay.
So we just want to stop the ability for this machine to produce.
Okay.
But
I think that's a common misunderstanding oftentimes, because I think people think that I break that beam and it shuts it down. It's safe.
It should just stop the action.
Stops the action.
So if we're talking about press, it's going to stop the RAM from moving.
Okay.
Press brake, RAM again, but it could be in front of a robot. Mm-hmm. Then it's going to stop the robot's motion. It's not going to shut it down, because we got to know where it is in the sequence. We have to know. We can't. We have to know the count, if it's 200 pieces or what part it has to pick up. So I mean, there's a whole bunch of, basically, if you think about it in the way of the computer, there's a bunch of stuff that it needs to know where it's at.
Okay.
And that's the way that the controls are. They're basically just computers almost anymore, and to where you program it and then it runs. So we want to interrupt that program. We don't want to stop it.
Right.
Because then production's screwed up. The only reason we want to stop that is lockout, tagout. That's when we have to eliminate all energy sources.
Right. Okay.
But as far as safety and devices, we just want to stop the hazardous motion, whatever that is.
Okay.
And this is kind of the other issue. We may want to stop the hazardous motion of one piece of equipment, but also whatever feeds it.
Okay.
So like in a robot situation or an automated piece of equipment, if I break that light curtain, I don't want just, if there's machines feeding, I I want to also shut those down as far as the running is concerned.
Okay.
So that gets a little bit complicated, and the automation side of things, which is where manufacturing's heading and anything in industry is heading, gets a little more complicated because machines are tied in together. So the devices, though, are really good at allowing us to tile that in and shut things down.
Okay.
So anyway,
interesting. Which it helps to have this team of engineers in the background that are actually understanding how these things communicate with the equipment.
Yeah. And then
interesting.
Some dummy like me out there taking pictures and writing down information.
Yeah, just put them up. Just put up the light curtains. Can't you just put up light curtains? Right. There is a little bit to it.
Yeah.
It's interesting, though.
I want to talk about the light curtains real quick. So these all have infrared beams and a series of infrared beams. They can be, there's a minimum object sensitivity, which is basically the amount of room an object can go through. And so you have point of operation light curtains that have a smaller minimum object sensitivity, so that if I put my hand through it, it would recognize it.
Okay.
But you also have perimeter light curtains. And similar to the guard, the perimeter light curtains, the beam spacing's further apart.
I didn't know that.
So it can be further. Yeah, it can
Look
be.
at you, man. Good for
What, you're shocked that I actually know this stuff?
No, I love it when I learn something new. I didn't know. It makes sense because what you're more concerned about is someone just walking through the area. So rather than a finger or a hand making its way through the beam.
Well, and the other thing is these can go up to about 8 foot tall. So in perimeter situations, just think about it. You can think about a pure cost. I put a bunch of beams in here. The smaller it is, the cheaper, the less expensive.
Yes.
If I get an 8 foot, I want to not have to put 100 beams in there versus putting 20.
Yeah, it makes perfect sense.
Yeah. And these are adjustable too. So the minimum object sensitivity can be adjusted a little bit within this.
Okay.
And then there's things like blanking and other things. So if you have protruding objects, you can tell it in this field here, just it's okay. Like, let's blank this out, meaning we're not going to recognize this. So anywhere else, we're going to stop it, but for this point.
Okay.
So
I've seen that on brakes, like press brakes, for example, where you have a couple of sequences where you drop the RAM, in the presence of the light curtains, and then you have to mute a few so that you can insert the materials, and it might make a bend or something that would otherwise trip it.
Right.
So they are really sophisticated.
Oh, completely. You can, and what these do, these tie into a laptop, and you can configure them basically.
Amazing.
Yeah. So the other thing is you got to test them though.
Okay.
So every shift they're supposed to test them, and they have these.
Thank you
these
for saying
rods that you take. If it's done every shift, I'd be really surprised.
Well, but it's supposed to be, right?
It's supposed to.
Yeah.
And then you take this rod and you go down, and these beams will light up. So they're red beams, and they'll light up. What'll happen also is, depending on the light curtain, it'll have a green-red light for indicating green is good and red is something's blocking it.
Okay.
And so when you do this, you should see red, green, red, green, red, green, red, all the way down.
As you're testing it.
Yeah, as you're testing it.
Fantastic.
And I've seen some of the OSHA guys walk by with folders and test too. Just to see if the light curtain actually is operating.
I used to just stick my hand in there while it was running and watch the entire everybody on the operating floor would run out going, what the hell, Just checking it out, man.
Doug, that isn't the best way to test it.
That's not a great way. No. Have you seen people waste? I don't mean to be giving people bad info, but to defeat these things, or
all the time. So the blanking feature is great unless it's abused.
Right.
Right.
You just blank the whole thing out.
So. Yeah, you can blank everything out except the top beam.
Right.
And operators get smart and they understand it, and so it is something you have to supervise.
Yeah.
And the reason why you do testing and the reason why you do other things to stay on top of that and supervise it, because the minute you get comfortable is usually when something happens. So I'm going to talk about just a couple stories, and some people might know of them or have been involved in them. But you think about these light curtains here; they're across a press. There's going to be, let's see if this will stand. Nope. So behind this or wherever there's going to be access around it. Like you can't put it super close to the machine. Usually there has to be a post or something that's holding these, and there's still a gap. Okay, so you have that there. There's still a gap back here between the machine where we are and the light curtains.
Right.
And the operator's out here.
Mm-hmm.
So I got called into a place that was paying people on piecework, because that's how it happens sometimes, is you pay people on how productive they are piecework. And these light curtains were active and working great, but they didn't have guarding back here, so they didn't have a guard like this on the backside. So they had access. And two guys thought, oh, I know how we're going to do this. We're going to kill piecework. So you are going to put the piece in. I'm going to hit the buttons, and we're going to click through this fast. Well, what happens is they didn't get the timing right, and a guy lost a hand. So you need to guard it too. Like, you can't just rely upon this. This is a first step.
Okay.
But if there's access around, under, through, or over, you got to fix that too. This doesn't just end your problem, or this isn't the complete solution. You could put more beams back here. This can be these can be called in cascade.
Okay.
They can be tied together.
Okay.
So we could put a series of 4 light curtains together.
Okay.
And you basically then you tie 2 and 2 together to block that out. You can put mirrors and reflect.
I've seen that.
Yep. You can put mirrors.
Kind of bouncing it around the perimeter of a... Okay.
So that's a good way to do it. But the most probably cost-effective way is just wherever you don't need the light curtain and the access, just guard it.
So
just keep people out.
So what types of environments will these not work in? I mean, and I'm thinking in particular...
So they're getting better all the time.
Are they? Because I'm thinking like really dusty environments, or even wet environments maybe. There might be some limitations, but they're addressing that?
It is getting better all the time.
Okay.
And I've had some that didn't work in areas where I'm like, oh, it's going to work, and then like steam. I had steam once screw things up, and I'm like, oh.
Interesting.
So we had to put a fan there to block the steam out.
And that worked?
It kind of worked.
Okay.
I wish it had worked better.
Yeah, but there's not always a perfect solution.
No.
And so oftentimes you have to...
dust and dirt, because we can keep this clean all we want, but it's gonna get dirty.
Okay.
So you'll have to maintain it and clear it. So yeah, those environments don't work really well. Wet is not necessarily great, but you can. There are some ways to
work around
to solve that. Yeah, I mean, so it's getting better and better all the time, and the technology is getting better. And then there are other ways. So we're just looking at light curtains, but there are scanners out there.
Talk about that. That's interesting.
Scanners are amazing, because you can set whatever area you want a beam to go out to. So there's a distance, and anything that senses within that distance or that shape, it alerts it. So you can set different zones with scanners. So if you just want to, like an alert where a light goes off to say, hey, you're in an area you're not supposed to, you can set it like that.
Without actually interrupting the machine.
Down.
Okay.
And then maybe maybe that's the alert zone or whatever you want to call it. And then there's a safety zone beyond that, shorter distance that shuts things down.
What kind of equipment do you see that stuff used with?
This is where we get into automation, but also on simple things like pipe benders or things that have.
That's what I was thinking.
Yep.
Yeah.
So that's a common thing on a pipe bender nowadays.
Okay.
Because it can scan out a way, and if you have this big piece of pipe sticking out and moving, it's getting moved.
Right.
Then
it's hard to fix a guard around that. I mean, it eats up so much space, though, if you're using a fixed guard in that application.
Correct. So you can take a scanner and put out like a semicircle or up to 270-degree range.
Wow.
And then you can also sit there and program it. If there's like a post or something in the way, you can tell it, yeah, we're going to go up here, and then we're going to go back around the post.
You can notch it out like that?
You can notch it out.
Wow, I didn't know that.
So you can program it so that if there are objects there, you can tell it to ignore that object or that thing.
Wow. Interesting.
Yeah. So it's very useful.
Yeah.
In that way, and we see it a lot. Now the thing is, it's going to send out a beam. It doesn't like cover the whole area. So that's its one downfall.
Okay.
Is that this can cover a long area.
Right, but this
the beam could do the same.
It's just setting out a flat mat.
It can't send out a whole array of lights.
Giving you 3D necessarily, but that's probably coming at some point.
It was. There's more camera technology going into these nowadays, and so I think that's coming, and I'm trying to catch up on it.
I'll bet that's really interesting. The camera technologies, and I know in the smart manufacturing workplace of the future, the equipment and the employees are going to be like linked almost, it knows you when you approach the machine. It knows your working operator parameters, so the machine adjusts itself almost like your car seat, you have your selector, or whatever. I think it's really fascinating. What you guys are doing.
What's happening is, though, that the manufacturing technology is getting ahead of the safety technology, or not the technology, but the acceptable safety standards.
Oh, yes. Yeah.
So technology is taking leaps forward in how they're doing things, especially in robots and robotics, and also just automation in general. And even ANSI and then the robotic industry is still a little bit behind on what was this safe. We don't know, and robotics industries, of course, they want to sell machines. They're like, yeah, it's totally safe. so we gotta. There's a little bit of a woe factor there right now. But I know they're trying to work on it. I know Rockford Systems kind of backs off of some of that and just says we're going to stay on the safety side.
We're going to lean toward the safe side,
and we're going to go with the ANSI regs that we have now.
Okay,
and we're going to say that if you're sitting next to or standing next to a robot or something that's moving parts, we're not going to be okay with that. We're going to make sure that there's a safeguarding in between there.
Okay.
But that technology is really getting to the point where I could be the robot, and you could be putting in parts, and you can be right there.
Yeah.
It's there now.
It's fascinating.
It's just not sure how 100% safe it is, but you can make it safe for sure. But
it's coming, right?
But, it's there.
It's coming.
Talk
a little bit about the concept of two-hand controls.
So when we talk about devices, we still have the old standard of two-hand control, meaning that we're going to go ahead and have buttons or sensors that someone's going to have to hold their hands on at a safe distance.
It's going to keep their hands out of the danger zone.
Yeah, out of the danger zone for a safe distance.
Okay.
And so that's still the old two-hand control standard, and there's lots of things about in the control, like you can't completely just hold down. You have to release. If you release one hand, you can't tie it down, can't be defeated. There's a whole bunch of standards for that. But it works great because basically it keeps somebody's hands out of the point of operation hazard. So you can have a machine that doesn't need the guard and doesn't have a device if you have two-hand control. The only thing that we're worried about now is other people.
Yes, thank you. Excellent.
And the other people story is I was working on a machine once, or I got called on a machine. There were light curtains on the front, and the operator was completely connected, but this machine was really big, and it had a big die on the front of it, so you couldn't see around it. Well, two guys were on the back of it, you and I, just talking about the day's story, the water cooler kind of thing, and a guy reached out and put his hand down on the back side of this die, not thinking, and somebody started it, and he was in a pinch point. And so the problem there is we have to make sure that if someone's doing maintenance or we're just talking or someone's there, that they can't be in a hazardous situation. The guy up front, perfectly okay. He had light curtains, or if he had two-hand control, that person up front, that worker is safe. But we got to make sure everybody else is safe also. So that's where the physical guard, or you could have a perimeter-style beam back there.
So we've got the point of operation and typically the operator.
Yeah.
Then we have the perimeter of the machine, which is like people that are passersby or working adjacent that might find their way into one of those danger zones.
So here's the problem, though. Let's say we have that perimeter guard and I break it. Now I'm inside. That That doesn't shut off the machine entirely if the operator can just go, oh, I don't know what happened. I'll just reset and go. Somebody can still be in there. We call that pass-through. So someone can actually be in front of the light curtains. And you'll see if light curtains are set way out, someone might be able to actually operate the piece of equipment inside the light curtains. Or if you're crafty, you might have the guy on the outside pushing the buttons and the guy on the inside feeding parts. Well, that's a bad scenario. But so we call that pass through.
Okay.
And there are ways to take care of that. You can use light curtains in a horizontal, not vertical anymore, but horizontal field.
Oh, interesting.
Or you can use a scanner.
Okay. Or
you could use matting. There's pressure-sensitive matting out there that's probably the most economical way to do it.
Okay.
And it's just basically this mat where these sensors are there, and if someone stands on it, the sensors connect, send a signal, and stop work.
I've wondered about that. So I've wondered about like the, the interlock to gate scenario. And I open the gate, I go in to do some type of maintenance, or I'm checking on something, whatever. I'm out of line of sight. The gate gets closed, the interlock is reset, and the machine will run. And, you may not be aware that somebody's in there. That's always kind of scared me. I like the mat idea, and even the horizontal beams. I'd not thought of that.
Yeah, so these can be set up so they're set like this, and now you have a bigger area of coverage. Right. Now, to your thing about going inside of a gate, when they come out, ANSI requires there's a reset. Okay. So somebody's got to take knowledge and action to reset that.
It won't just restart when the gate closes.
It's not supposed to.
Right.
But that doesn't mean
that it won't. It's not supposed to.
That doesn't mean that whoever set up that control didn't set it that way, because, man, that'd be a lot easier and more productive than just start up.
If I have to go over there and restart it every time.
If I have to push a button, that's not that's too hard.
It's cutting into my piecework.
Well, that's part of it. And we see a lot of that.
Interesting.
I've got a scenario on that regard where I'm going to be honest. I looked at the piece of equipment before this incident happened, and I'm like, oh, it looks good. They had all the right stuff that I could see. And then somebody got into a situation where they said everything going right. They loaded parts into this carriage, and then the carriage went to an automated system, and there were sensors that would tell it when it was ready to go and all this. So anyway, it was a complicated system, but just realize that everything in that system has to be rated for safety. And what happened is this person got caught up in the carriage, and the sensors said, let's go, because they were not the sensor. Anyway, this is going to get complicated. But along the way, a sensor failed. Okay. It wasn't a safety-rated sensor.
So it did not fail into a safe mode?
Correct.
It just failed into the go mode?
And it just went go. And then somebody got luckily they pulled their arm out of this, but it didn't. I mean, their arm was all scraped up, but could have been carried up through. It would have been a fatality.
Yeah.
So basically what I'm saying is, even like you mentioned, like you go in the gate and you come out, you have the interlock, you have to make sure everything is thought of and everything's safety rated. What made me think of it is we talked about, you just close the interlock back and we start up again. And that's kind of what they were doing, is they put in sensors to make it work well as a machine, but they weren't thinking exactly on the safety of it.
Interesting.
And so what happened is it was in an oven, and the sensors weren't rated for heat. And so they had failed, but so they weren't the right sensors. Okay. And it's complicated a little bit because there are all so many pieces of working parts, but you got to think of that safety along every very little part.
Right.
So we can't just throw an interlock in and just shut it and run back, because we have to think, okay, is anybody out there? Is everybody out there? Has the work all been done? Have we checked everything? To your point, if we have hazardous area that we don't want someone in, then let's put matting in there so that if someone is in there and we don't know, if they're just, even in a situation where, let's say, they become overheated and they're in there and they're passed out or something, we want that to not run. We don't want somebody to come up and say, Jim, are you in? Nope, he's good.
Yeah. Must have gone to lunch.
It. Yeah. So all that should get looked at and gets a little complicated. But don't just think you've put on light curtains, you're fine, or
right.
We physically have a guard on there now, we're good. We got an interlock. Well, does the interlock go to the right control? Do we have the right things in the control that looks at reliability and redundancy in the circuitry? And that's where Rockford, brings their expertise, is they can look at all that and tie everything in to make sure there's reliability and redundancy, and other people too. But I mean, I'm just saying that's where those experts come in. So part of the problem is sometimes you just hire the local electrician and he's not used to this, and he just throws in starters or controls.
Oh, I see that all the time.
So do I.
Yeah.
That's part of the problem. I get called in on this.
So are you doing these things for companies now in this capacity? Will you be available to go in and help them do that hazard analysis? Yeah. Because in all likelihood, they're not asking the right questions, or they're not digging deep enough into the assessment. Hey, we got to put a thing here, and they're done. But like you said, you have to really. This requires some anticipation. What could go wrong where?
Right.
What am I missing? And that's not an easy thing for people to do, because when you look at the 212, it's not a prescriptive standard. It's performance based. You have to guard this equipment, but it doesn't really tell you how. And so it's not necessarily intuitive to be asking these. So are you going to help people do this?
Yeah.
Is that part of what your role will be?
So the role for me is to basically walk people through this, like to show up your facility and you go, hey, can you just look through my equipment and tell me if I need it and what I need to do. And then I'd quickly do a walkthrough and go, oh, yeah, you've got issues here, here, and here. What's your next steps? Let's target. Do you have so ANSI has a new and relatively new way of looking at it. And then the assessments, they want to do you have a high risk, a medium risk, or a low risk? So we can look at it that way, and I'd probably come in if you were the customer and say, okay, let's go look at these pieces of equipment. Okay. We have major point of operation hazards here, here, and here. So we probably want to prioritize those. And to do those, we're going to have to bring some people in to take a look at it. It's going to be days worth of work to really assess everything. So I'll come in and give somebody the heads up, and we'll probably put a plan together.
Okay.
And at that point, it's free. But after that, to bring people in and really have a detailed assessment, then that ends up being charged. And then they set up a plan, because the proposal will be generated on how you're going to fix it. And then from fixing it, then how you're going to install it and down the line. And then, that's how it works. But that's what I do. And for anybody out there who just needs help talking them through, I have this situation or I have that situation. Yeah. Contact me, give me a call. I mean, that's kind of what I'm there for, is to establish the expertise out in the world,
right,
and get people to communicate and reach out about their issues and try to walk them through it. They might be able to get through it themselves. Let's just talk about that. You might be able to do the work yourself.
In some circumstances, maybe. I mean, I know people have called me and asked about machine guarding, and if it's not something that they want me to come on site and do, and I certainly don't have your level of expertise, but I can send them to the Rockford website, which is really useful. They give examples of different guarding approaches or solutions that, in some circumstances may be enough for that employer to do the right thing. Yeah. But some of this stuff gets a little...
If it's a drill press or a lathe,
right.
Shields are
some basic stuff.
Shields are what OSHA requires or ANSI requires. So that's pretty simple things, and we can help do. Physical guarding is something everyone can do. It may get complicated beyond that. Okay, I want physical guarding. Okay, how about interlocking it? Oh, we want to interlock it. Well, then we should probably look at this further, because maybe your control can't even accept an interlock,
right.
or maybe your control isn't. I mean, what we have problems with is, like you said, resets and things. But we may even have a control that does what's called a ghost cycle or something, where it's not checking itself, it's not safety rated. So it may start up on its own if something happens within the control. So that's that. The
ghost in the machine.
And it's been there. I've walked up on machines where someone will say, "Yeah, this ghost cycles," and I'll be like, "Okay," and it'll cycle, and then it'll be like, Okay. Oh, it just went. Whoop, it just went. How? Like, I mean, that's a scary thing. So that's in the control itself. Something's wrong. It's not about the guarding. It's not about the two-hand control. It's not about the light control. Yeah. There's something within there that's not working. And the redundancy within the ANSI standard, the requirements for redundancy and reliability, take that out. Okay. I mean, if they're really done to that point, you're not going to have that.
Okay. What do you know what that ANSI is right offhand? Is this B11 that you have referenced?
Yeah, the B11 standards are that's a general standard, and then there are machine-specific standards, all the ANSI machine-specific standards also. But B11 is a general safeguarding, and it'll talk about that.
Okay.
And then 217 talks about it. So 1910-217 talks about it on mechanical power presses, and it addresses redundancy and reliability, control reliability in that. But ANSI's the place to go for it.
Okay. I want to ask you a little bit about stop time.
Yeah.
Can you talk about what stop time, that concept, what that means? And
hold on, I gotta go away for a second.
Okay.
I don't know. Maybe I won't go away. I just got to pick up the.
Okay, man.
So.
Oh, you got something.
I got an antique stop time measurement device. But the newer ones look like this also.
Okay.
So it's this little device, and it has some sensors in here.
Oh, shoot. I've seen one of those, man.
Have you seen this old one, though? The new ones are yellow.
What I got trained on.
So the new ones are yellow, but basically you have this cord that hooks up. So this is going to hook to the machine.
Yeah, we can see that.
Okay. So this is going to hook to the machine, and it's going to either this way or this way. And there's just something in there measuring the travel.
Okay.
And then there's a device that you pull out that looks like this way.
There you go.
And it looks like, and it has a plunger right here.
Yeah.
And that plunger basically activates. So if you have a light curtain, the plunger goes out, and so it breaks the beam. You'll have an attachment on here, and it breaks the beam, and then the signal then says, how long does it take to stop? So break the beam, start the recording, stop the recording when it stops, and then it gives you a measurement. So that's the device. But why we need stop times is because we don't know where to put these if we don't have a stop time. Like a hydraulic press or a hydraulic piece of equipment can stop pretty quickly, like 6 inches. Like that's your safety distance.
Right.
Something mechanical, 14. So if we how do we know where these are at in the safe distance? And there's a calculation that's used for safe distance. There's a hand speed constant that's added in, plus the time it takes for these to communicate and all this stuff. There's a formula that's used to get that stop time and give you that safety distance. So stop time measurements are needed at least annually to make sure the equipment is still stopping in the
that's an annual
time
thing.
frame. Should be.
Okay, interesting. I did not know that. Okay.
Yeah. You want to make sure.
3 things I didn't know.
You want to make sure that piece of equipment is still stopping in the time that you thought it was
within the parameters that we've already. Okay, so let's talk about this concept a little bit. If I'm using a device that is going to send a signal to the machine to stop the action, it doesn't necessarily happen instantaneously, which is what you're saying. I break this beam, and now the machine just doesn't immediately stop.
It may not.
They may continue to travel. If it's like a revolution type, it might continue to revolve. It might continue to descend.
It might have a motor that doesn't stop.
Doesn't have a brake necessarily.
Yeah. So we have all these things out there. We have if you think about it, we're creating a lot of force that we need to stop.
Yeah.
So whether it's a 50-ton press or it's a drill, there's still a lot of force being generated by a motor or by whatever is generating a ram or whatever, and we need to stop it. It's not going to happen
it's not instantaneous.
No.
And I think a lot of people are under that misconception that it is.
Yeah, I see light curtains all the time. They're right up against a piece of equipment, and you're like,
Yeah, I can break this, keep walking before that thing even gets the signal necessarily that it's supposed to stop.
Yeah, the signaling and everything's milliseconds.
Yeah, okay, man.
It's pretty fast. No, but you're right. But the way it stops and the momentum, that can, even the quickest stuff is still inches away.
Yeah.
I know people would love it to be right there, but it's not. And that is kind of the false sense of security sometimes.
I think so too.
So two-hand control also, if you put it right up there against a piece of equipment, do you know whether that's the right distance or not?
Right.
So
when
you
you release those, it might still continue to move.
Correct.
That's really interesting.
Correct. So that's the reason for the stop times.
Okay. And you guys do that?
Yep, we do that. And
because
then also
I don't know
when you're setting it up.
Yeah.
Like if you're setting up a piece of equipment and putting light curtains on it for the first time, you want to take stop time. So, but it's easy. You just take a series of 10 and throw out the highest and the lowest. And
you have a nice average that will.
Yep.
Okay.
That's basically how you do it.
Okay.
Yeah. So we have a team that'll come out and do it.
That's really interesting.
And then you can record it, and then you of course keep that file somewhere so you have documentation and all that. But it's just a really good way. And have I been on places where I've taken stop times and I'm like,
not even close.
We aren't even close.
Yeah.
And not only are we're not even close. I'm not so sure at some point that I can stop this if someone gets in it. Like there are some where it's like, we're giving them a false sense of security because this is going to continue to the end.
Right.
It's not going to stop. It might stop at the bottom. We don't want that. Like we want it to stop before it comes to that contact. Now, I've been to places like that, and it's shocking to people. Like it's shocking to people when you show them
what?
Yeah, they're like, oh, then someone could really get hurt. And you're like, yeah.
That's
so we're gonna have to do something to the equipment, or we're gonna have to place these part far back, or we're gonna have to put a guard in front of it, or we're gonna have to figure out how you're gonna still produce parts effectively, but still be safe to do it. And that's part of the role that I also play is when I get in, it's working with the customer on productivity still, because that's key.
Got to be able to make widgets, man.
We can bubble wrap everything, and then nothing gets done, right? So
got to make widgets.
So we still got to make parts, and we still got to be productive. And speaking of that, though, somebody asked me once, well, guarding and everything, it's all an expense, and it slows things down, and it's just not a good thing. And then I'm like, no, you got to understand, if something goes wrong on that piece of equipment, you're going to be shut down for weeks, maybe months. And so if I keep that machine running effectively and keep people safe, it's actually a time savings. Like if there's injuries, you're going to have a massive slowdown and an interruption of production that may just really cripple your business. So this is a way of keeping that in a way of insurance or something like that. It's a way of making sure that your production stays solid for forever, and stays solid. The other thing is something happens, nobody wants to work on that piece of equipment ever again.
Right.
You're up. Doug, you're up next.
Next man up.
I like
Who's got both hands? Get up there.
I mean, I don't want to be grotesque, but that is really what the employees think. And I've been there, too, where the employees are like looking at me.
Is it okay?
You're sure it's safe if I do this? Yeah, it's safe now. Like I can tell you what happened, and I can tell you how we fixed it, and it's okay now. And you don't want employee retention and then loss of production are two things that are just killers for people who manufacture things or people who make anything.
And who ignore a lot of these.
Yeah, so we can look at it like, it's a huge expense, but you can also look at it as it's one of the things that keeps our company running. And if it doesn't work, it could really affect us massively. So
definitely.
That's the way I always kind of look at it and talk to people.
So let me ask you about occasionally I will see the pull cord that is essentially a corded e-stop of sorts around, oftentimes rollers and things that are difficult to guard otherwise.
Right.
What's up with that shit? I mean, what is that?
It's the best way you can really do it. That you just said it. The roll forming machines are probably the hardest machines to
really hard to guard. Granted,
you're taking this huge piece of metal or some usually metal.
Typically.
And you got to load it in this thing. You're trying to form it into a circle.
Get a curve in it.
Yeah, it's like, how are you going to keep people out of it? Without automating it, it's really difficult. So the e-stop cable, which also could be on lathes or other things.
I've seen them in a few
where
places.
there's large areas that you have to cover, and that area still has to be open to do work.
Right.
So the kick cables are something, or a bump bar.
What did you call
bars.
them?
Kick cable. Well,
okay.
when you put them around the...
So you're catching it with your feet as you're being pulled through the rollers? That kind of thing?
There isn't a good way. The best way probably to do it
would be to automate it somehow.
Is likely automated or use a scanner.
Okay.
Or something that is a little more in-depth. I mean, you can put the piece in there and go use the two-hand control and walk away. You can still do that. You don't have to hold on to that big piece of metal usually. And if you do, well, then maybe you should put a table in there, or maybe there are other ways to handle it. But the go-to easy button is the cable. But yeah, I would definitely do it a different way.
Is there a distance requirement for those, as you would find with like a?
It's really not a good way on that piece of equipment.
Because if you were going to put it far enough back, you wouldn't be able to engage with the machine. You wouldn't be able to feed the machine if you're doing it manually. Right. If you have those set back far enough that would make a difference. They are just this hope and a prayer, basically, kind of a...
So, and then you got to talk about, well, where is the hazard? And the hazard is when it initially starts, or what we call like ingoing nip points. I mean,
before you've got the piece in there.
Yeah. And we can go technically into it like a 1/4-inch gap is not considered an opening or a point of operation hazard according to OSHA.
Right.
So when we put that piece part in there, we no longer have like a point of operation hazard because it's tight in those rollers.
The gap is filled. You're not going to be able to get in that.
But we have the ingoing nip point, which is also on conveyors, pulleys. Everything is that ingoing nip point. And that's the part. So an ingoing nip point has to be covered or protected, and that's just really hard to do. I've seen people guard the front of a roller with guarding, so you can't physically get to that point of action that's pulling it in. So that's a way to do it. You could physically guard the front, or you could put a light curtain across the front. Question is, how quickly would that stop? So then you get into that, where you're like, because the roller's not going to stop very fast. So you're in it, and it stopped, but you didn't get pulled all the way through. I mean, that's the cable thing too, is like, okay, I've gotten caught in this. How do I stop it? I think that's like the bare minimum safety you'd want to look at. And then there's the best practice, which would be figuring out, can I put a physical guard there? Can I put a light curtain that's going to stop it quicker or keep me from even getting to it? Because honestly, I really don't need to touch that roller. I don't need to actually feed it in there. It's a piece of metal. It's not like a fabric. It's not loose. You're just gonna. It's just gonna slide in there. So some of that can be handled, but it's a difficult thing to do. But I think I described several ways to go beyond that cable.
Yeah, that's really interesting.
Yeah, and then like the e-stop, it has to be able to stop every hazardous motion and all that. So we have a control there that we have to work with. Maybe the light curtains. Maybe there isn't a control that really works with the light curtains on just a roller, because basically it's just a big motor with some rollers, and it may even reverse if it's really sophisticated. I mean, but other than that, it just goes or it stops. So if you don't have a control, you may not be able to tell it go or stop. So in that case, it gets a little more complicated. Like, okay, now we got to put a new control on it. And it gets expensive, and somebody says, well, my roller only costs $10,000. Now you got $10,000 of equipment on here? And that's where it gets difficult. And it's like, I'm sorry, but that's the safety part of this. And you have a piece of equipment, it has to be safe. Per regulations and per being a good business owner, you got to keep people from getting hurt. I can't, as a safety thing, you still have to guard it. You still have to do everything. Even if the guarding is more expensive than a piece of equipment, that's the requirement, and you should do it. I mean, that's the tough part about my job.
Yes, convincing
really telling telling somebody, oh, yeah, I know you just bought that
Well,
that press from Menards, but it doesn't even meet any standards. And by the way, we have a whole bunch of issues now.
And that's that's a very important concept, that the end user is ultimately responsible for this.
Absolutely.
It's not the OEM didn't send it, so it's not my responsibility. It's not.
It is stated
a valid
and complete black and white written language. The manufacturer of the piece of equipment is not responsible for the safety of the workplace.
That's the user's ultimate responsibility, and that was always a very contentious conversation with an employer when I was with OSHA. That it didn't come with any of these guards. It didn't. This is how they show it in their manual and all, or on the website or whatever. And you're like, I get it, but ultimately these are your employees. It's your responsibility to protect them, and that's a tough one. Yeah, it would be nice if the OEMs would do that.
I mean, some of the OEMs do a good job. They really do. Or they'll have packages that are available that are really good. I mean, I'm not going to say that the machine industry is out to get people. They're not at all. They do what they there are some really good ones out there that do a good job. And they're the ones that are easy to walk up to that piece of equipment and go, okay, I know. Okay, they have some safety stuff already in here. This will be easy for us to work with. So there are plenty of those out there, but to the and you're talking about, it's still on the safety person, the production manager, the company owner, to make sure that even if the machine is provided with the safety products, whether it's light curtains, whatever, that it meets what you need it to meet.
Right.
Because I've seen plenty of people where I've walked in and they're like, yeah, it has light curtains. And I'm like, oh, great. Well, let's take a look at it. And then I'm like, oh, but you didn't protect the backside. And by the way, these light curtains are right up against the machine, and there's no way it's stopping in that distance. And, yeah, you have light curtains and all this, but your guys are turning off the light curtains or just something. They're just certain things that even if the OEM produces or provides safety, it doesn't mean that it's completely safe. And I think that's tough for me to explain to people when I get out there. Because then they get mad at the OEM. They're like, wait, they told me this is all I needed to buy. And then they're like, yeah, well, maybe, but you do things differently, or this isn't a full solution here. So
this is really challenging because of the subjectivity of that concept of, is it guarded well enough? I mean, you could talk to 10 different OSHA guys, and they would give you 10 different opinions on one piece of equipment of whether that is adequate guarding or not.
Correct.
It's not black and white, unfortunately. So it really does help to have someone with expertise and a lot of experience, having seen thousands of machines, to tell you, I think these vulnerabilities are too much. We need to address these. Because that's a really difficult thing to know. Is this guarded well enough?
Yeah.
Most people think they've guarded stuff well enough. And, my perspective is often different, and yours, I'm sure, is often much different. That's a tough one.
Way much different, because I've heard about the odd scenarios where I thought things were okay, and then they weren't. Or I've talked to people who have thought things were completely 100% good, and then you find out, oh, well, we missed this or that.
Right.
And that's where somebody like Rockford Systems or others that come out and do things like that can really look at the details that you're not aware of, or you've never had the experience in, or I'm sure most safety directors would open up, or safety people, or even production people would open up a control and go, yeah, I don't know what I'm looking at.
Oh, hell yeah, man.
I mean, when I first started, I'm like, it's a bunch of wires. I mean, I don't know what they do. And now at least I can go, oh, there's a safety control, and okay, here's a transformer, and go through everything you need to go through, because not only do we have to think about, when we go through this, not only do we have to think about OSHA, we have to think about ANSI, but we also have to think about NFPA. Because in our world, we don't, NFPA is a big part of looking at the standard. Is the energy transformed? Is it the right motor? Does it, when the machine turns off, and if it turns back on inadvertently, does it start right back up again? So there are different motors that are required so that they drop out.
I know in woodworking and in 213, there's a lot of that.
There's a lot of that, but NFPA addresses it. So, if you have this gets into a little bit of lockout tagout too for this, is that when you turn off a piece of equipment and then you plug it back in, you don't want to start it.
Right.
You don't want to start just right then and there. You want to be able to go through an action. Mm-hmm. So that's like with your red e-stops that are required to retract out so that you have to pull it up to then start again. Mm-hmm. I don't know if you know. But anyway, so all that kind of relates to the NFPA standard that talks about basically the energy sources. So we look at transforming things down and making sure that the equipment doesn't fail and that the operator doesn't get in contact with voltage or energy that it's not supposed to.
Okay.
Does that make sense?
It does.
Yeah.
Very interesting.
So we look at all that.
We've gone way over time, man. Oh my gosh.
Well, we got to save it for next time.
Have you been waving at me, Dylan? Have you? I'm sorry, man. I've just been totally.
Hey, we got into it.
Totally into the conversation.
We were geeking out for a second.
I think we're going to have to continue this conversation at some point, man, because there is so much more to talk about.
I think
we barely scratched the surface.
I think your comment on people and automation, we could have a whole thing on that. And I'd love for people to reach out to us and tell us what they want us to talk about.
Yeah, what would be interesting for them to discuss.
Tell us what we want to dive into.
Yeah, but I apologize. We've gone way over, so we're going to have to wrap this up. Jason, it's fascinating, man. Really interesting. I thought you were just like some kind of gym rat guy or something, man. You really know some shit.
Okay, we see each other.
No, it's really interesting stuff, and I appreciate your sharing this stuff with us. How do people get a hold of you if they want to? We'll put your email address or contact in the liner notes.
Perfect. Just reach out to me that way.
That would be great.
It's just jason.mcmeen at rockfordsystems.com. So
okay, fantastic.
Reach out to me that way. And
you're going to be an incredible resource, brother.
Good.
That's fantastic.
I mean, that's the plan. And I'm the one that, we have training seminars and things, and you can call into Rockford and get some information, but I'm the on-site guy that's like going to show up and tell you where to start with.
Will you be doing seminars here in this area, or how will that work? Or will we be going to Rockford, Illinois, or
you can do it's either online or in person.
Okay,
monthly.
Okay.
So there's a big space there that'll hold, I don't know, like 50 people or 60 people or more.
Fantastic.
And then they go through a 2-day seminar of walking through basically the regulations, but also real world situations.
I love it.
And then online too, but we'll do on-site stuff too.
Fantastic.
We just did training in Chicago at a big company that had us come in and did a full-day training on lockout tagout and a full-day training on machine guarding for all their safety people across the U.S. So
wonderful.
Yep.
Fantastic. Well, we're going to have to do the lockout tagout, too.
Yeah.
We got a lot to cover.
There's some cool stuff there. I really like what we've done at Rockford Systems.
We'll have to get you back on and have to go down the lockout tagout rabbit hole. Awesome.
Yeah,
appreciate it, man.
All right.
Thanks, everybody.
Thanks,
man, fascinating information. I'm sorry we went over, but most of you have a long drive this afternoon, hopefully. So you'll be able to cover the entire thing. Get in touch with Jason if you have questions, needs, whatever the case might be. It is, in my experience, this is something that everybody has a need for, and probably everyone could do a little bit better. So don't hesitate to reach out. Check out the Rockford website. I get on there periodically too. There's a lot of interesting, and things are changing.
Yes.
So if you didn't have a solution a year ago, there may be a solution now. Don't give up hope.
Absolutely. Yeah, thanks.
Appreciate it. Have a great weekend, everybody, and we will talk to you again soon. Later.